For those of you who are interested, I've actually provided an alternative method to solving each of those examples we had seen in the lesson. This is not a requirement or anything like that. You don't have to know this, but for those of you who maybe feel like there's got to be a better way, this I wouldn't say is better. It's just a little faster. But along with faster means that it has the potential to be a little bit more confusing. But that may not be the case. So this video is worth watching. This method I like to call the multiplication grenade. And for those of you wondering, this is Hulk Hogan approved. So how is it done? The first step is to find a common denominator for all terms that are fractions. And we'll see this in just a minute. The second step is to multiply every term in the equation by this common denominator. Let's try it on one of the examples from our lesson. So the first one, it looked exactly like this. And the first step in this kind of multiplication grenade method, I call it that because you're really just eliminating all fractions in one foul swoop. And the way that we do that is we look at all the terms that are a fraction, and in this case all of them are, and we would find a common denominator for all of those fractions. And in this case we know that it'd be 21. So now we ask ourselves, okay, let's change all of these. Let's multiply every single term by 21. So this doesn't change the equation whatsoever. So I'm just multiplying each one by 21. And what does that do? So you may be wondering, well, how does that, what does that do for us? What it does is now this cancels out, because this is really like, you could sort of think of it as this instead, as a multiplication, 12 over 1 times all of these terms. And because it's a common denominator, it means every single one of these denominators are going to cancel out. 3 goes into 3 once, it goes in 21 7 times, and in this one on the right, 7 goes into itself once, of course, and goes into 21 3 times. So what we're left with here is an x minus, we've got 7 times 4 on the top, 28 equals, and 3 times 5x, 15x. So here we saw that we totally eliminated all of these fractions by multiplying every single term by the common denominator. So if you're comfortable with that, if you're comfortable with seeing how this was actually done, you'd end up with something that's actually quite simple. And in this case, we're simply just moving the x over the right hand side. So there we are. And well, we can do 15x minus x, that's 14x's, and divide both sides by 14. And what we have is x equals minus 28 over 14, which equals minus 2. And that's the same answer we got before, but it may be less work depending on the setup of the question. Let's see the second example. Same one again, and in this case we're looking at all the terms that are fractions, and that would be this one and this one, and we want to just find a common denominator, which of course in this case it'd be 63. Oops. So now we just want to multiply every single term by 63. And again, I'll write it like this, just so that we can see how these cancellations are happening. We can't forget the 5. We have to multiply everything by 63. Just finish writing it out. There we go. And now we can see how these cancellations are brilliant. So 7 will go into itself once and into 63 9 times. Well, 63 times 5, that'll just be what it is. This 9 goes into itself once, and it goes into 63 70 times. Or 7 times, sorry. Okay, so what do we have left? The bottoms here are just 1 times 1, and that's the clever part of all this, is that you end up with just the denominators completely missing. But what we have in this one here is that it's 9 times 4x plus 1. So we have to use the distributive law. That'd be 36x plus 9. So that's a result of 9 times 4x plus 1. Here we've got 63 times 5, and I just remember from the last lesson that it's 315. Otherwise, I'd be doing it on the right-hand side here. And, of course, on the other side of the equal sign, we've got 7 times 2x plus 3. So we have to, again, use the distributive property. So 7 times 2x is 14x, and 7 times 3 is 21. And once again, here we're left with something beautiful, and that is we don't have any fractions at all anymore. And we'll just put the x's on one side of the equation and the numbers on the other side of the equation. And what we have left is 22x equals 327, and x equals 327 over 22. And as a mixed fraction, it's 14 and 19 over 22. 19/22, I should say. So there we are. That one's done. This last one, we just saw this equation, but here it's a little bit different because all three have fractions, but one of them has an x on the bottom. So we're kind of wondering, well, how does this one work? First off, I'm just going to change this fraction on the right-hand side to an improper fraction. It's not necessary, but it just makes things a little bit easier. So that's 41 over 8. So what would be the common denominator for x, 2, and 8? Well, the common denominator would actually be 8x. And I just know that I can get 2 to 8x by multiplying by 4x. I can get 8x to 8x by multiplying by 8. And 8 to 8x by multiplying by x. So I'll actually write that out so that we can physically see it. But this one I'll be multiplying by... Oh, sorry. Now, once we know what our common denominator is, now we can do the same thing and just multiply every single term by 8x. And once again, I'll represent it like this, just so we can see the cancellations. It's not necessary to write it that way if you can kind of see what's going on, but I'll write it that way anyways. Okay, and time for some cancellations. Those x's obviously disappear, and what we're left with is 32 for that one. That would just be 8 times 4 plus, and for this one, 2 goes into itself once and 8 4 times. So what we're left with is on top we've got 4x times 3, which is 12x. Obviously the denominator's gone, that was the point. And this right hand side, 8 goes into itself once and once there. So what we're left with for there is 41x. Okay, so let's toss that other x term to the right hand side, and we end up with 41x minus 12x on the right, which is also 19x. Oh, no, sorry, 29x. And we want to divide both sides by 29 to get rid of the 29 with the x. And we're left with x equals 32 over 29, or 1 3/29. Okay, so that's the multiplication bomb. That's one other way to solve these equations, maybe a little faster than what we had seen in the actual lessons. I hope you enjoyed.